Today's lesson, we're going to take a look at graphing and writing equations in standard form of hyperbolas, another type of conic. So big objectives today is to be able to analyze and graph equations of hyperbolas and then use equations to identify types of conics, and that'll happen on day 2 tomorrow. So there's some vocabulary words to start. First off, a hyperbola is a set of all points such that the absolute value of the differences of the distance between each focus is constant. And really this is that other conic that we get slicing through that inverted cone picture that we kind of took a look at in our first beginning of chapter 7. But with hyperbolas, you come up with what's called axes. So if you remember the major and minor axes of ellipses, we come up with what's called the transverse and conjugate axes. That's really how we graph hyperbolas, is to sketch those first. And it's always twice the length of A, and the conjugate axis is always twice the length of B. One thing you want to note is that the transverse axis is not necessarily longer than the conjugate axis. It really depends on, how it's orientated, vertically versus horizontally. But take a moment and write these vocabulary terms down in your notes so you can pause the video if you need to. So these are the standard forms of equations for hyperbolas. So notice the standard form is very similar to ellipses. The only difference here, notice, is that you're going to have a minus sign in between. Okay, so there's a minus sign in each situation here. So instead of a sum between those two terms, there's going to be a difference between those two terms. So anytime you see really any squared term that's involving a negative coefficient, it's going to end up looking like a hyperbola. So when we start putting things into standard form and determining the types, that's one easy way to tell, is if you have a negative squared term, it's going to automatically be a hyperbola. The center is always found by taking h comma k, just like with all the other standard forms. But then notice here, c squared is the sum of a squared plus b squared. So it's not, if you remember, c squared equals the difference of the two, and that's for mainly hyperbola, or that's for ellipses as well as parabolas, to find that c value to determine where the foci are. But here you end up doing the sum of both of those squared. So that's one big difference there for hyperbolas. And again, if the squared is sort of, if you have a positive x squared term, so that it's the x minus h on top first for that first term, then it's going to be horizontal orientation. So that means it's going to open up to the left and right. But if your y squared is positive, right, that's listed as your first term, then it's going to be orientated vertically. So that means your hyperbolas open up or down, or down, I should say. So here's kind of all the parts about the standard form of a hyperbola. One thing you want to note is a lot of things are the same for like your vertices, the foci point. We still need that value of c to be able to sketch where the foci are. But notice we have sort of additional asymptotes that might need to be sketched. Now we'll talk more about this on day 2 of the lesson, on actually how to find the equations of those asymptotes. But for now, we're just going to sketch them as dotted lines. But tomorrow we're actually going to determine the equations of it. And so one thing you want to note is, however it's labeled, so if you notice here it's x squared is positive, so it's going to be opening it to the left or right. The distance of your first vertice point, so once you plot that center point, the distance of that first vertice is going to have a distance of a, and then the distance between your center and foci point, that's going to have a distance of c. When we sketch this hyperbola in the next couple slides, what you're going to do first is find what your a value is and what your b value is, because that's going to tell you what the distance between the foci are. But also when you sketch the b value, you're going to find that distance from the center, and you're going to draw a box. Once we draw the box that's defined as a by b as an area, then we're going to connect the corners of those boxes to represent your asymptotes. And then once you have the asymptotes, it's really a matter of sort of sketching the curve that sort of hugs those asymptotes and those other foci points. So sketching it's not too difficult to do. In fact, I would always encourage you to sketch it first before you ever sort of find these things second. So, but there's formulas there if you want to jot those down as far as in your notes, because remember, you can use your notes on the next assessment coming up. So take a moment and jot down these couple images, and we'll take a look at a couple examples on the next few slides here. All right, so very first question says graph the hyperbola given by, so it's telling you a hyperbola. So the first thing we want to figure out and jot down is sort of how it's orientated. Is it orientated vertically or is it orientated horizontally? Notice in this case we have a positive x squared that's first, right? The x squared term is first, it's positive. So that tells me that my hyperbola is going to be opening up to the left and right. So it's going to look something like this, okay? My a value ends up being the square root of the number on the bottom here. So a ends up being the square root of 49, which is 7. And then your b value is the square root of 81, which ends up being 9. So something in the back of our mind we want to figure out is what the c value is, because remember the c value is taken by the sum of those two squared. So if I find the c value here, that would be 49 plus 81. So adding those up looks like it gives me an answer of 130. So c is going to be the square root of 130, which on the calculator ends up being 11.4. So we got our a, we got our b value, we got our c value. So now let's try to sketch this. So the center, notice the center, we don't see anything in parentheses on top, so we're going to treat it as x minus 0 squared and then y minus 0 squared. So the center here ends up being at the origin, 0, 0. From the center, your a value is going to be the distance to your first vertice. And so since that a value is 7, we're going to go 7 units this way, plot a point, that's our first vertice, and we're going to go 7 units to the left and plot a point, that's going to be our second vertice. We also want to sketch the b value too, because to figure out our asymptotes, we're going to be able to sketch the distance of a, distance of b, make a rectangle, and then we'll be able to draw our diagonal asymptotes here. So the b value is going to be the distance between, let's see, the box distance vertically here, so that's going to be a distance of 9 this way, and then we're going to have a distance of 9 down below. So if I draw my box here, what the dimensions of a 7 by 9 might look like, is there we go. And then the diagonals of the box is where your asymptotes are going to be. So we're going to have one diagonal asymptote that goes through the origin and cuts through the diagonals there, and we're going to have the negative asymptote, negative slope, that cuts through the diagonals there. Once I have my sketch, it's really just a matter of plotting the focus points and then plotting and actually sketching your actual hyperbola here. So remember, the focus points is always from the center and it passes through the vertice there. So if it's a distance of 11.4 to your next focus point, then I'm going to put a point right at 11.4, which is just beyond my arc here. So that would be one focus point here. And I'm going to subtract 11.4 in the other direction. So I'm going to roughly put that point just beyond the x-axis there on the left side there. So that'd be my other focus point. And then lastly, if I were to sketch the curve, first off, it has to go through the vertice, and then your branch is going to sort of hug along that asymptote line. So this is what one branch looks like, opening to the right. Would be sort of hugging the asymptotes there. And then if I draw my other branch opening to the left here, going through that vertice, and again, hugging the asymptotes that extend outwards, there's my picture of the hyperbola. So if I asked you what is the equation of the major axes or the transverse axes, so remember the transverse axis always goes through the center to the vertices. So the transverse axes as an equation would be y equals 0 there. That would go through the, basically the x-axis would be your transverse axes, and the conjugate axes would then be the y-axis there going through the origin. So the conjugate axes as an equation would be at x equals 0. All right, let's take a look at another one before I have you guys try one on your own here. So here we're graphing the hyperbola y plus 4 squared over 4 minus x minus 2 squared all over 9 equals 1. So the first step is to figure out how this is orientated, which notice we have a y squared, positive y squared first. So that's going to be orientated vertically. So I know in the back of our mind that our hyperbola is going to be opening up and opening downwards like this, okay? The center, notice the center is going to be at positive 2 comma negative 4. So if I sketch my x and y axes here, positive 2, negative 4 is down here, so that would be where the center is. My a value is the right underneath that first value, so a is going to be the square root of that number, which is 2, and then your b value is the square root of that number, which is 3. So that means I'm going to go a distance in the y direction up 2 and down 2, so that's going to be my first focus point. So that would be vertice 1, sorry, and then down 2 would be a vertice number 2. And then the co-vertices are going to be to the right of it, 3 and subtract 3. So if I add 3 to the right for my center, that's going to be my shouldn't say co-vertice, but that would be my other mark where I'd make my rectangle here, right? And then if I draw my rectangle out of the a and b values there, that allows me to then sketch my asymptotes through those diagonals. So you're going to have one asymptote going through the center through those diagonals, and then you're going to have another asymptote going through the center between the other set of diagonals. But remember, your orientation is going to be sort of vertically, so we know the hyperbola is going to look something like this, where it hugs the asymptotes, goes through the vertice point there. But the other thing I just need to sketch is my focus points. And remember, the focus is found by that c distance, where we take the sum of your squared terms. And so if I take the sum of my squared terms, which ends up being 4 plus 9, I get 13. So we get the square root of 13, which on my calculator ends up being 3.6. So that means I need to add 3.6 vertically from the center. So I get a roughly about right here would be one focus point, and then I need to subtract 3.6 down below there. So obviously if you had the x-y axis with some nice coordinate grids, you can actually get that specific point if I ever ask you what the focus or the focus points are and the vertice points are. But there's your sketch. So let's take a look at this one here now. Now notice this one is a case where we don't have it in standard form. So before we graph, really the goal here is to be able to get it to standard form. As with ellipses, what you first want to do, first step, is sort of group the like variables with its squared term together, and then any sort of constants on the other side. So notice we don't have any constants on the left side, so we'll just keep it as equal 28 on the right side. But if I shuffle terms around here by grouping the squared and the like variables together, shuffling the left-hand side becomes this. And then so what we're going to want to do is complete the square for the x variable and complete the square for the y variable. When you complete the square, remember, you gotta, if there's any coefficients, we gotta factor that out first. So if I factor out the 4, what I'm left with on the first two terms would be an x squared plus 6, and then I'm setting myself up for completing the square there. And then for that second term, we want to factor out a negative here. So then what I'm left with is y squared minus 4, and then I'm setting myself up for completing the square with that part too. So remember, when you complete the square, the trick is you take that middle term, right? We divide it by 2, and then we square it to figure out what we put there. Remember that coefficient that's in front of the parenthesis there will affect what you add to the other side. So even if I divide that by 2 and square it, I get positive 9. I'm going to want to add 4 times 9 to the other side, which is 36. So don't forget about that if you have any coefficients. You have to add the multiplication of that coefficient in front. And so if I do the same process for the second term there, I take that negative 4, I divide it by 2, and then I square that answer. That's going to be positive 4. There is no coefficient in front, but remember there's a negative out in front. So that negative sign is going to affect what you add to the other side. So technically we need to, instead of adding 4, we need to subtract 4 because that negative is going to affect that term. On the right side, on the left side, what you're left with here would be 4 in parentheses, and then that factors into x plus 3 squared. On the second term there, you're left with y minus 2 in parentheses squared. And then on the right side, if I add all those terms up, right, 28 plus 36 ends up giving me 64, and if I subtract 4 off of that, it looks like I end up getting 60 on the right-hand side. So remember, any equation in standard form is always set equal to 1, so I just need to, now to make it equal to 1, divide each term by 60, and then simplify those coefficients if I can, right? 4 over 60 in that first term can be written as over 15, 1 over 15, and then that second term doesn't reduce, so I just have to keep that as over 60, but now it's equal to 1. So this would be a case where your A value would be the square root of 15, right? Your C value would be this, your B value would be the square root of 60. Your C value would be the square root of the sum of those, 60 plus 15, so that ends up being square root of 75 essentially. So you're going to be dealing with some decimal points as you're plotting them, but the big goal is there to get to the standard form to be able to do what we did on the slides before. All right, let's see if you can try a couple on your own now. So here we have part A is listed in standard form already, so already set up for you guys to sketch, but then part B, notice you're going to have to put that into standard form first. So take a moment, you can pause the video, try these on your own, and then we'll take a look at our answers in a little bit. Good luck. All right, so if we take a look at the first one here, you should have found out that your A value was the square root of 4, which is 2. My V value, which is the square root of 9, which is 3. And your C value ends up being the square root of the sum of those, which ends up being square root of 13, which we've seen that one before. That ends up being 3.6. So if you're going to sketch this, right, first thing is to plot the center, which is going to be at 3, negative 1, according to the parenthesis values there. So at positive 3, negative 1 is right here. So that's where the center of my hyperbola is going to be. Since the x squared is positive, right, it's going to be opening up to the left and right. So I know my parabola, or hyperbola, sorry, is going to look something like this. And so to get the C value, which is the distance from the center to your first vertice there, that's going to end up being 2 units away. That's going to be my first vertice there, so that's your V there. And then I'm going to do 2 units away there. The other side, that's my other vertice. And then remember that other value just tells you how to create that box. So if we go 2 in that direction, then we're going to go 3 in the other direction, put a point, and then we're going to sketch that rectangular box through those values there. So there's my rectangular box where the diagonals going through the center there is going to end up being your asymptotes there. So we have one asymptote there going through that first diagonal, and then we have another asymptote going through the center through that other rectangular diagonal there. And then, so the hyperbola itself is going to look something like this, where it goes through the vertice, kind of hugs the asymptotes on both sides there. So that's what the branch is. Whoops, let's make that a little better there. There we go. So this is what our branches of hyperbola. So the last thing we really need to sketch is just those focus points. And so from the center, if I go 3.6 away to the right, which ends up being sort of between that integer there, and then 3.6 away to the left, my other focus point, label them. There's our answer. So one question I might say is, what's the transverse, right? If I ask you questions about what's the transverse axis, that's the one that goes through the center and all points there, the vertice and the focus points. So that transverse axis is going to be at y equals -1. And then the other one might be asking for what the conjugate axis would be. And so conjugate axis would be the one that goes vertically, so that would be at x equals the x coordinate of that center point, which is at x equals 3. So with this one, in order to graph it, it's really about putting it in a standard form first. So let's just check if our standard form correctly here. So the first step is to organize it. Variables, like variables with the squared term, any constant terms move to the other side, which there isn't any. So just shuffling the left side around, I get this. And then if I'm setting up for completing the square, remember you got to factor out those coefficients. So if I factor out a 9, what I'm left with is x squared minus 2x, and then I'm setting myself up for completing the square there. And in that second two terms, you're going to have to factor out a -4, and you're left with y squared minus 4y. Again, set myself up for completing the square work there. And remember, when you complete the square, you take that middle term, divide it by 2 and square it. So in the first case, I get positive 1. But remember, you got to add whatever the coefficient times that value to the other side here. So that's going to be a plus 9 to the other side. And if I do the same process for the next one, taking that middle term, dividing it by 2 and squaring it, I get a plus 4. But remember, I got to add the product of that coefficient times 4, which ends up being negative 16. So I got to subtract 16 off to the other side. So the first term becomes 9 and then a parenthesis x minus 1 squared. And in that second term, you're going to have 4 and then in parenthesis y minus 2 squared equals, if I add all those up, right, looks like I get 52 minus 16, which ends up being 36. And to set it equal to 1, which is standard form, you just got to divide that right side to each term and reduce, right? 9 over 36 can be written as 1 over 4, and then the 4 over 36 can be written as divided by 9, and now it's equal to 1, where I can identify my A, identify my B, identify my center to be able to plot and graph this. So that concludes sort of the first half of today's assignment.